I know what you're thinking to yourself. You're thinking, well, what will it look like if I used a Venn diagram on an invalid argument? How will I actually know the argument's invalid by the Venn diagram? Well, that's a good question. So here's our syllogism. All civil rights are things worth dying for. All things worth dying for are things worth killing for. Therefore, all things worth killing for are civil rights. Okay, first thing we do, we render this argument down into symbolic form. I chose C to represent civil rights, D, things worth dying for, and K, things worth killing for. I've got three terms that appear exactly the same way, 2 times each. They're all plural nouns or noun phrases. All right, I can also now verify that my argument is in standard form because I'm going to check my Venn diagram work by consulting my inventory of valid forms when I'm done here. And so I've determined this is in standard form. The predicate of my conclusion appears up here in the first premise. My minor term K appears right here in the second premise, and my middle term appears in both premises but not the conclusion, and each term appears exactly 2 times each, the exact same way each time it appears. So now I'm ready to mark my Venn diagram. I've got 2 universal statements here, so it doesn't matter which one I begin with, so I'll just go ahead and start with the first one. It says all C's are D's. So I'm going to come over here to my C circle, and I want to turn out the lights in any area of my blue circle where there would be C's that are not also D's, because I want to represent all C or D. That means that I'm going to shade out areas 6 and 7, because if there were anything in 6 and 7, those would be C's that are not D's. And I'm trying to show that every single C that exists is also in the D circle. Okay, so we shade in areas 6 and 7, and we turn out the lights, all the C's are D's. Now it reflects that. The second premise says all D's are K. That means I'm going to come up here to my D circle, and I want to turn out the lights in any area of the D circle where there could have been D's that are not K's, because I want to show that all the D's are K's. So what am I going to shade? Yes, areas 1 and 4, you guessed it. Now I'm done marking. And I want to look to see if my Venn diagram represents the conclusion statement. Does this Venn diagram show the statement, all K are C? And the answer is no. Maybe there's some K's that are C's right here in area 3. Maybe not. There could be some K's right here in area 2 or area 5. And if there were, those would be K's that aren't C's. Now, we don't know if there's anything actually there. Maybe there's not. Maybe it really is true, if we had more information, that we have to turn out the lights in areas 2 and 5 as well. And in that case, all the K's would be C's. But that's not what we can do based on the information we've been given by these 2 premises. Areas 2 and 5 remain with the lights on. There could be something there. That means that even when we assume these premises are true, we can see a way that the conclusion could be false. And that tells us this argument is invalid. But of course, we're going to check our work by consulting our inventory of valid forms. The form of this argument is AAA, and my middle term is sloping upwards from left to right. That tells me this is figure 4. So I pull out my unconditionally valid forms inventory. I go to figure 4, and I don't see AAA there. So again, that just confirms for me I did my Venn diagramming correctly. This is, in fact, an invalid argument. Now, you might be thinking, well, hey, what about the Aristotelian inventory? What about all those conditionally valid forms? The only argument forms that appear in the conditionally valid inventory are arguments that have 2 universal premises and a particular conclusion. And this argument's conclusion is universal. So there is no argument on the conditionally valid forms inventory that has a universal conclusion. So I don't even have to bother consulting that. I just know that this argument is invalid from both the Boolean and the Aristotelian standpoints.